Okay, what's up? Boulevard Broken with another tutorial. Let's get a little louder. And this is going to be stupid slots. Let's check that we're not too stupidly close. There we go. Okay, so the point of this module, it's actually quite a neat puzzle. You're going to find what each of the buttons do. You're going to use that to get conditions about the number, and then you're also going to use those to set it to a number that fits those conditions. So there are 6 buttons that move up and down, and they might not do what you think, but 2 of them will just not work. 4 of them will. 2 on the top, 2 on the bottom. So the first thing you're going to want to do when you get this module is find which ones work. That doesn't really matter, but more importantly, find the values for them. So because 1 on the top and 1 on the bottom always don't work, I'm just going to consider 2 of them. 4 of them. Top left, top right, bottom left, bottom right. And the one that doesn't work just won't be counted. So this one on the top left goes 258 to 275. So that's a difference of positive 17. So that's my top left. Top middle, 250 to 225. So that's going to be negative 25. And then I know this last one's not going to do anything, so I'm not even going to write it down. Then bottom left, 229, 233, 237. That's plus 4. Finally, that one's 221, 205. Is negative 16. Okay. Now we have these, and this one won't do anything. I got lucky. These 2 buttons just do nothing, so it's just those 2. So now we have our top left, top right, bottom left, bottom right. Now we have 3 conditions to find. First 2 conditions will be actually just, you'll see them on your screen. So we'll take the top button on the left. So first we're going to do these for these rules for the left and these rules for the right. That was a horrible way to highlight them, but you'll see what I mean. So our left buttons are 17 and 4. The top button, 17. Modulo 5 is going to be 2. If you don't know how to take a modulo, you would just do 17 minus 5 until it becomes between 0 and 5. Or plus 5, as we'll see later. But that's going to be a 2. So the thing for 2 is number must be multiple of. So it's a multiple. And then 4 modulo 5 is obviously 4. So that's the bottom button, and that's going to be 4 or 9. So I'm going to write it like this. I know our number has to be a multiple of 4 or 9. Now, second one, negative 25. Well, we can add 5 to that repeatedly, and then if we do that, we'll get 0. That's when it'll be between 0 and 5. So negative 25 modulo 5 is 0, so that's the number modulo 5 must equal. I'm just going to write it like that. The negative 16, we have to be careful. This modulo 5 is not 1, actually. It's 4. Because we kept adding 5 to this. This would be negative 11, and then negative 6, and then negative 1, and then 4. So we don't just lop this number off for negative numbers. So because that modulo 5 is going to be 4, it's going to be also 4 or 9. And then our final constraint, which won't be on here, but will be in the manual, is essentially just modulo 10. The last digit, the number modulo 10 has to be same as one of these modulo 10. So modulo 10, it has to be either 7. 17 modulo 10 is 7. 4. 5. Negative 25 modulo 10 is going to be 5 regardless. And negative 16 is also going to be 4 modulo 10. The way I do modulos for negative easily in my head is just, if it's positive, you just take the last digit. If it's negative, subtract from 10, if that makes sense. So like 10 minus 6 would be 4. 16 modulo 10, negative 16 modulo 10 would be 4. Hopefully that makes sense, but if you do this module more than once, you'll get used to it. So now we have our constraints, and we have the number at 189. Now we just need to solve the puzzle. So 189, is it a multiple of 9? Yes. Modulo 5, is it 4? Yes. Its last digit, however, is not 7, 4, 5, or 4. So we need to change that. We obviously wanted to keep it a multiple of 4 or 9. What I'm actually going to do is try to get this a multiple of 4. Because getting a multiple of 4, modulo 5 equals 4, modulo 10 equals 4 actually sounds the easiest. So if I add 17 till it ends its 4, is 274 divisible by 4? No. But if I keep adding 4, actually that won't work. But I'm just going to keep adding this until I get 400, 404. Obviously, there could have been a better solving process for that, but I'll just talk through what I just did. I saw that the number I was on, it ended in 4, so it satisfied these bottom two, but it wasn't a multiple of 4. It's good to know your multiple rules for this. The easy way to know if something's a multiple of 4 is see if the last digit and the second to last digit is a multiple of 2. So 404, 0 is a multiple of 4, 4 is a multiple of 4. So that satisfies our first condition, and it ends in 4, so that satisfies our second two conditions. Our thing wasn't, so I just pressed an odd number until it reached the parity I wanted. There are many ways to get through this. You can make a system of equations. You could just BOGO sort until it works. I like to make a midpoint of the two, do what you want, but here we're at 404, and if I click submit, it's going to do funny things, and it's going to solve. Whee! Okay, so that's stupid slots. I'll do one more as an example, but if you get it from here, shout outs to you, and you can leave now. But I'm going to do one more. Let's do 381. So top left is going to be minus 10. 97. I can't see. .409 goes to 421. Oh. It's going to be 12. I swear I can do that in my head, and I didn't just use my calculator. That one's always going to be empty. That's going to be positive 5. Shush you. Middle button does nothing, so this is our bottom right. 34, 27, 20, that's negative 7. So let's get our trusty chart. That's going to be 2 zeros, so it's going to be... this one's probably going to be easier. So 2 and negative 7 is going to be 3 modulo 5. Am I right? Yeah, I'm right. It's going to be... Okay, and then finally, last digit has to be 0 or 5. It's actually going to have to be 0 or 5 because modulo 5 is going to need to be 0. So I don't really care, but I'll do those just for show. And then we're at 420. Is 420 divisible by 8? No, it's not. It is divisible by 3, though. So modulo 5 is 0. It's divisible by 3, and modulo 10 is 0. So that's actually just an answer. Neat. Okay, so yeah, that's the tutorial. Hopefully you can embrace the stupidity yourself. So yeah.